Starship keeps exploding. 3 Block 2 failures, Ship 36 destroyed, Artemis 3 delayed to 2027. But what if SpaceX already has a moon rocket ready to go? Falcon Heavy sits on the pad with 27 engines and 11 perfect launches. It can throw 16.8 tons to the moon, more than Apollo needed. While Blue Origin celebrates one orbital flight, SpaceX could put astronauts in lunar orbit tomorrow. So why isn't NASA using it? What's stopping this proven beast from saving Artemis? And how did Blue Origin just get completely humiliated in this space race? Let's dive right in. The $2.9 billion disaster unfolds. Here's what NASA doesn't want you to know. Back in 2021, SpaceX crushed Blue Origin and Dynetics, winning the $2.9 billion Artemis contract. Everyone thought it was over. SpaceX had conquered the moon race. But 3 years later, Starship Block 2 has exploded, 3 times in a row. Ship 36 detonated during a simple static fire test. The U.S. Government Accountability Office dropped a bombshell warning. Raptor engine delays pose the biggest threat to America's return to the moon. Let that sink in. The engine designed to land humans on lunar soil can't even survive basic ground tests. NASA quietly moved Artemis 3 from 2025 to mid-2027. Then Amit Chatria, NASA's deputy administrator, delivered the crushing blow. They might not even complete the propellant transfer demonstration by 2025. That's the make-or-break test where Starship proves it can refuel in orbit. Without that milestone, no moon landing, game over. The monster that's been waiting. But while everyone watches Starship burn, there's a beast lurking in the shadows. A rocket that's never failed, a rocket that could save Artemis tomorrow, a rocket NASA's been ignoring. Falcon Heavy. Most people think it's just 3 Falcon 9s bolted together. Dead wrong. This monster was engineered from day one to carry humans beyond Earth orbit. SpaceX built it with 40% structural safety margins above flight loads, higher than rockets that actually flew to the moon. 27 Merlin engines, 5.1 million pounds of pure thrust. Compare that to NASA's precious SLS at 8.8 million pounds. But here's the knockout punch. Falcon Heavy costs $90 million per launch. SLS. Over $4 billion. Wait, it gets better. Falcon Heavy hurls 16.8 tons to trans-lunar injection. The Apollo command module and lunar module combined, 15 tons. This beast has more raw power than the rocket that actually put Neil Armstrong on the moon. So why isn't NASA using the proven winner sitting right in front of them? The hard truth about lunar capability. Here's where space fans get confused and NASA gets nervous. Can Falcon Heavy actually replace Starship for lunar missions? The answer will shock you. Falcon Heavy can absolutely blast humans to lunar orbit, launch a modified Crew Dragon, swing around the moon, come home heroes. Mission accomplished. But landing on the surface? That's where reality hits hard. Starship HLS is designed as a mobile lunar base. 50 meters tall, 9 meters wide, complete with an elevator for astronauts. It lands directly on the moon like something from science fiction. Falcon Heavy's second stage? Built for one job, launching payloads from Earth orbit to deep space. It's not a lander, it's a delivery truck. But here's the twist NASA doesn't want to admit. If they used Falcon Heavy for lunar surface missions, they'd go back to Apollo-style operations. One launch for crew, another launch for a lunar lander. Dock in lunar orbit, land, rendezvous, return home. Could SpaceX build a Falcon Heavy compatible lunar lander? Absolutely. Would it take years and cost billions? Also absolutely. But it would work, unlike Starship, which keeps exploding. Blue Origin's humiliating reality check. Speaking of things that don't work, let's talk about Jeff Bezos. While SpaceX wrestles with Starship explosions, Blue Origin finally had their big moment. New Glenn launched on January 16, 2025. After years of delays and broken promises, Bezos finally got his heavy lift rocket off the ground. The result? Complete embarrassment. They lost the booster. The first stage, nicknamed "So You're Telling Me There's a Chance," crashed into the ocean. Traveling at Mach 5.5, the 3 BE-4 engines failed to reignite for landing. Gone. Destroyed. Humiliated. Meanwhile, SpaceX has successfully landed Falcon Heavy boosters 33 times, Blue Origin couldn't stick one landing on their debut flight. Their lunar dreams? Even more pathetic. Blue Moon Mark 1 is supposed to land in 2025, but it's only hauling cargo, no humans, just supplies. Their human-rated Mark 2 lander won't fly until 2027 at the earliest, and that's just for an uncrewed test. Compare that timeline to SpaceX. Even with Starship delays, they're planning an uncrewed lunar landing demo in 2026. Blue Origin is 3 years behind, and they just proved they can't even land a booster. But wait, there's something even more embarrassing about Blue Origin's approach, the cryogenic nightmare nobody talks about. Both Starship and Blue Moon face the same technical nightmare, the problem that could kill both programs. Cryogenic propellant storage in space. Starship burns liquid methane and oxygen. Blue Moon uses liquid hydrogen and oxygen. Sounds simple, right? Wrong. Dead wrong. Liquid hydrogen boils at -253 degrees Celsius. Even the tiniest heat leak makes it evaporate into useless gas. Managing these super cold fuels in space for weeks is like keeping ice cream frozen in Death Valley. Starship needs to prove it can transfer massive amounts of propellant between vehicles in orbit. That's never been done at this scale. Never. Each Starship HLS mission requires 10 to 15 tanker launches just to fill up in orbit. 10 to 15 chances for catastrophic failure. Blue Origin's solution? Their cislunar transporter must refuel Blue Moon Mark 2 in the bizarre, near-rectilinear halo orbit where NASA's Lunar Gateway sits. More moving parts, more complexity, more ways to fail. But here's what NASA won't admit publicly. Falcon Heavy uses room-temperature kerosene and oxygen. No exotic cryogenics, no boil-off nightmares, no crazy orbital refueling stunts required. Just proven technology doing what it already knows how to do. So why is NASA betting America's return to the moon on unproven technology when the solution is sitting right there? The scale war. Bigger isn't always better. Let's talk raw numbers, because they tell a shocking story. Starship HLS can haul 100 tons to the lunar surface. Massive, game-changing, revolutionary. Blue Moon, Mark 2, a modest 20 tons including crew and cargo. Falcon Heavy to lunar orbit, 16.8 tons maximum. But here's what the numbers don't tell you, and what NASA is terrified to admit. Mission complexity changes everything. Starship requires multiple refueling flights for every single mission. Each Starship HLS lunar landing needs 10 to 15 tanker launches just to top off the tanks in orbit. That's 10 to 15 individual opportunities for mission-ending failure. Blue Origin's approach seems simpler but hides deadly complexity. One New Glenn launch gets Blue Moon Mark 1 to the lunar surface, but crewed missions demand their cislunar transporter system for refueling. More moving parts, more exotic technology, more risk. Falcon Heavy? One launch gets crew to lunar orbit and back home. No refueling choreography, no orbital assembly nightmares, no exotic propellants waiting to boil away. Just proven technology executing a proven mission profile. But there's a deeper question here. Is NASA's obsession with massive payload capacity actually making lunar missions harder than they need to be? The Dragon Transformation Challenge. Here's where engineering reality meets political necessity. Crew Dragon was built for low Earth orbit taxi service. Getting it to the moon requires serious surgery. First challenge, Delta V. That's the rocket science term for change in velocity needed to escape Earth's gravity and reach lunar orbit. Current Dragon engines can't generate enough push alone. SpaceX would need to add a service module or use Falcon Heavy's second stage for the lunar injection burn. Second challenge, heat shield survival. Coming back from the moon hits your spacecraft at 11 kilometers per second. That's Mach 36. Blazing fast. Current Dragon missions only hit 7.8 kilometers per second returning from the space station. The Pixar-X heat shield would need major upgrades to survive lunar return speeds without burning up. Third challenge, life support endurance. A lunar mission takes 8 to 10 days minimum. Current Dragon flights to the ISS last mere hours. Longer missions demand better life support, more consumables, and serious radiation shielding for deep space exposure. But here's the plot twist NASA doesn't want to discuss. All these Dragon modifications are still easier than building Starship HLS from scratch. Dragon already flies humans safely. Falcon Heavy already delivers payloads flawlessly. It's evolution, not revolution. So why is NASA betting everything on unproven technology when proven solutions exist? The China threat that changes everything. NASA is sweating bullets, and for good reason. China is planning their own crewed lunar missions by 2030. Every Starship explosion makes international headlines. Every delay hands China more time to beat America back to the moon. The political pressure is crushing. Congress wants results. The public wants heroes. The space agency wants to avoid the humiliation of losing the new space race. Could Falcon Heavy buy NASA precious time? Absolutely. A lunar flyby mission with modified Crew Dragon could launch within 2 years if SpaceX focused resources on it. That's faster than any realistic Starship timeline, especially with Block 2 hardware still exploding. But here's NASA's nightmare scenario. They've already invested billions in the Starship approach. Switching to Falcon Heavy means starting over on lander development. It means publicly admitting their moon strategy was fundamentally flawed. It means eating humble pie on the world stage while China laughs. The philosophy war that will decide America's space future. This brings up the fundamental question that will determine whether America wins or loses the new space race. SpaceX's Starship philosophy? Go massive or go home? One ultimate rocket that conquers everything. Land anywhere on the moon, haul enormous payloads, eventually colonize Mars. It's bold, it's ambitious. It's also failing spectacularly. Falcon Heavy represents the opposite philosophy. Use proven technology, build on what already works. Take calculated steps instead of impossible leaps. Here's the brutal truth NASA won't admit. Apollo succeeded because it had laser focus. One crystal clear goal, get to the moon and return safely. Every system was optimized for that single mission. No compromises, no multi-purpose dreams. Maybe that's exactly what Artemis needs. Focus instead of fantasy. Proven rockets instead of experimental explosions. The real question isn't whether Falcon Heavy can get humans to the moon. We know it can. The question is whether NASA has the courage to abandon their failing strategy and choose the solution that actually works. Because while they debate philosophy, China is building rockets that don't explode. So here we are, NASA's betting America's lunar future on rockets that keep exploding, while a proven moon-capable beast sits waiting on the pad. The math is simple. Falcon Heavy works. Starship doesn't. Yet politics and pride are driving decisions that could hand China the ultimate victory in space. But maybe that's the real lesson here. Sometimes the smartest move isn't the flashiest one. Sometimes winning means choosing boring reliability over spectacular failure. What do you think? Should NASA swallow their pride and go with Falcon Heavy, or keep betting on Starship's explosive potential? Drop your thoughts below, because this decision will shape the next chapter of human space exploration. And if you're hungry for more space reality checks, hit that subscribe button. We're just getting started peeling back the layers of what's really happening in the new space race. The countdown to humanity's return to the moon continues. The question is, which rocket will actually get us there? NASA astronaut Don Pettit said SpaceX Dragon windows are stronger and safer than anything NASA ever flew. But how did SpaceX beat NASA's 50 years of experience? They stole the design from airplane windows. While NASA used heavy glass that cracked under pressure, SpaceX copied aviation's oval shape and switched to lightweight plastic. The result? Dragon survived 8 G-forces during emergency re-entry and built the largest space window ever. 2,000 square inches of pure Earth view. But why did NASA miss this simple solution for decades? And what other aviation secrets did SpaceX steal to revolutionize space travel? Let's dive right in. The fatal flaw that NASA ignored. It's 1954. A brand new British airliner called the de Havilland Comet is cruising at 500 miles per hour. Passengers are mesmerized by those massive rectangular windows offering breathtaking views of the world below. Then, mid-flight, the plane literally tears itself apart. 29 people gone. Instantly. The killer? Those beautiful rectangular windows. Every sharp 90-degree corner became a stress bomb, weakening the metal each time the cabin pressurized and depressurized. After 3 crashes, investigators finally uncovered the deadly truth. Square corners? Kill. But here's the part that'll shock you. NASA knew this. They witnessed the comet disasters. They understood stress concentration better than anyone. Yet for the next 50 years, they kept designing spacecraft windows with the same fatal flaw. Why would NASA ignore a lesson literally written in blood? The answer reveals everything about why SpaceX didn't just beat NASA, they demolished them. The Columbia wake-up call that changed everything. February 1st, 2003, Space Shuttle Columbia is screaming through Earth's atmosphere at 17,000 miles per hour. 7 astronauts inside, just 16 minutes from home. Then, catastrophe. Columbia disintegrates. Everyone dies.